Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first 5 parts of time, speed and distance where I have covered concepts like average speed, relative speed, boats and streams, races and circular tracks, and I have also explained some word problems on these concepts. So if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to do some word problems based on the concepts of races and circular tracks, which we have learned in the last video. So let us start with today's video. Let us start with this question today. A beats B by 40 meter in a 200 meter race. B beats C by 100 meter in a 400 meter race. C beats D by 150 meter in a 500 meter race. By how much meters A will beat D in a kilometer race, that is in a 1000 meter race. If you guys remember, in the first video of time, speed and distance, we have learned one thing, that is distance is equal to speed into time, and when this time is constant, we say that distance varies directly to speed. That means when two people are traveling for the same time, then the ratio of the distances traveled would be equal to the ratio of their speeds. Now, if we consider the speeds of A, B, C, and D to be capital A, capital B, capital C, and capital D, we can say that when A covers a distance of 200 meters, in that particular time, B covers a distance of 200 minus 40, that is 160 meters. So this ratio, that is the ratio of the speeds of A and B, will be equal to the ratio of the distances traveled by A and B. So if we simplify this, we can say that A by B would be equal to 5 by 4. So this simply means that when A covers 5 meter in a particular time, then B covers 4 meter in that particular time. In a similar way, if we consider for B and C, we can say that when B covers 400 meter in that particular time, C covers 300 meter. So B by C would be equal to 400 by 300, that is 4 by 3. In a similar way, if we consider for C and D, we can say that when C covers 500 meter in that particular time, D covers 350 meter. So this ratio will also be equal. So 500 by 350 can be simplified and can be written as 10 upon 7. Now, from this we can say that when C covers 3 meter, then B covers 4 meter. And from here we can say that when C covers 10 meter, D covers 7 meter. So if we take the LCM of 3 and 10, which is 30, and if we make both this to be 30, in that case, I can write this to be 30 and this to be 40, and this to be 30 and this to be 21, as I'm multiplying the numerator with 3. So I need to multiply the denominator by 3 as well. So this simply means that when B covers 40 meter, C covers 30 meter. And when C covers 30 meter, D covers 21 meter. In a similar way, here we have 4 and here we have 40 for B. So let us make this as 40 as well. So if this is 40, in that case, the numerator would be 50. So from here, we can say that when A covers 50 meter, B covers 40 meter, and in that particular time, C covers 30 meter and D covers 21 meter. So if the race would have been a 50 meter race, in that case, A would have covered 50 meter, whereas D would have covered 21 meter. Or if the race would have been of 100 meters, in that case, if A would have covered 100 meters, then D would have covered 42 meters. So we can say that in a 100 meter race, A would beat D by 100 minus 42, that is 58 meters. But the question has asked by how much meters A will beat D in a kilometer race, that is in a 1000 meter race. So in a 100 meter race, A beats D by 58 meters. So in a 1000 meter race, A will beat D by 58 into 10, that is 580 meters. In such kind of questions, we can simply write the ratio of the speeds of different persons and we can proceed in this way. Instead of solving this question in this way, I could have solved this question in a different way as well. Let us assume that the race is of 100 meters. So that means all these persons A, B, C and D will have to travel this 100 meters to finish the race. So in the first line, they're saying that A beats B by 40 meter in a 200 meter race. So we can say that if the race would have been 100 meters, in that case, A would have beaten B by 20 meters. So that means when A is here, B would be 20 meters behind A. In a similar way, when B beats C by 100 meter in a 400 meter race, that means when B covers 400 meter, C covers 300 meter. So when B would be covering this 80 meters, in that case, C would be covering only 60 meters. Again, C beats D by 150 meter in a 500 meter race. So that means when C covers 500 meter, D covers 350 meter, or when C covers 50 meter, D covers 35 meter. So when C would be covering 60 meters, in that particular time, D would be covering only 42 meters. So we can say that in a 100 meter race, when A covers 100 meters, B will be covering 80 meters and C would be covering 60 meters and D would be covering 42 meters. So when A covers 100 meters, D covers 42 meters. So in a 100 meters race, A will beat D by 100 minus 42, that is 58 meters. So in a 1 kilometer race or 1000 meter race, A would beat D by simply 58 into 10, that is 580 meters. So either we can simply write the ratio of the speeds of this person and we can proceed in this way, or we can simply think logically in this way to reach to the answer. Now let us say this question. In a race, if A gives B a head start of 100 meters, A wins by 30 seconds. Whereas if A gives B a head start of 150 meters, he still wins, but by 15 seconds. So we need to find B's speed in meter per second. Well, this question can be solved simply by framing the equation by using distance is equal to speed into time, but this would be a bit time consuming. So I would advise not to frame the equation and solve it in such kind of questions. Instead, let us simply think in a logical way. Here, when A gives B a head start of 100 meters, he wins by 30 seconds. Whereas when he gives B a head start of 150 meters, he still wins by 15 seconds. So we can see there is a difference of this 13 minus 15, that is 15 seconds. And this difference is because B was given an additional head start of another 50 meters. So we can directly say that B will be covering this 50 meters in this 15 seconds. So B's speed would be simply distance upon time. So this would be 10 by 3 meters per second. So in such kind of questions, it's always better to think logically instead of writing and solving the equations. Now, let us say this question. A and B are running around a circular track of length 720 meter at speeds of 12 meter per second and 18 meter per second respectively, starting at the same time from the same point in opposite direction. In how much time they will meet for the first time anywhere on the track and at the starting point. Since they are traveling in opposite direction, so the time to meet anywhere on the track would be simply distance, that is 720 meters upon the relative speed, which would be 12 plus 18. So this would be 720 upon 30, which will give us 24 seconds. So that means after 24 seconds, they'll be meeting for the first time. Now, to find the time to meet at the starting point, we can go via the number of meeting points or simply by taking the LCM. So let us first see how we can find the time to meet at the starting point for the first time simply by using the number of meeting points. Here, the speeds of A and B are 12 meter per second and 80 meter per second, which are in the ratio of 2 and 3. And they are traveling in opposite directions. So the number of meeting points would be simply 2 plus 3, that is 5. So A and B would be meeting at 5 different points in the circular track of 720 meter length. And the points would be symmetrical to each other, that is at a distance of 720 by 5 from each other. So the time to meet at the starting point for the first time would be the time to meet for the first time anywhere on the track times the number of meeting points, which would be simply 24 into 5, that is 120 seconds. Now let us see the LCM method to find the time to meet at the starting point for the first time. Time taken by A to complete the track completely would be simply 720 upon 12, that is 60 seconds. So that means after every 60 seconds, A will be at the starting point. In a similar way, time taken by B to be at the starting point would be simply 720 upon 18, which would be 40 seconds. So after every 40 seconds, B will be at the starting point. Now, if we take the LCM of this 60 and 40, we'll be getting that time for which A and B would be at the starting point. So the LCM of 60 and 40 would be simply 120. So that means after every 120 seconds, A and B would be at the starting point together. Now, instead of traveling in the opposite direction, if A and B would have traveled in the same direction, then the time to meet anywhere on the track would have been simply 720 upon 18 minus 12, as they were traveling in the same direction. So this would be 720 upon 6. So that would be 120 seconds. So that means after 120 seconds, they will be meeting for the first time. Also, the ratio of the speeds of A and B is 2 and 3. So when they'll be traveling in the same direction, the number of meeting points would be simply 3 minus 2, that is 1. So that means they would be meeting only at the starting point, and this would be after every 120 seconds. So 120 seconds is the time to meet for the first time, and it is also the time to meet at the starting point for A and B when they would be running in the same direction. Now let us say this question. P, Q, and R start from the same point at the same time and move along a circular track of length 3600 meters at respective speeds of 18 kmph, 27 kmph, and 36 kmph. Q and R move in the same direction and P moves in the opposite direction. So we need to find after how much time they will meet for the first time, after how much time they will meet for the first time at the starting point, and if they keep running infinitely, at how many points will they keep meeting. Since this circular track length is in meters and the speeds are in kmph, so let us first convert these speeds into meter per second. Now, if we convert these speeds into meter per second, then the speeds of P, Q, R would be simply 5 meter per second, 7.5 meter per second, and 10 meter per second. Also, Q and R move in the same direction and P moves in the opposite direction. So if we take the ratio of the speeds of Q and R, this would be 7.5:10, which would be 3:4. So that means Q and R would have 4 minus 3, that is 1 meeting point, and this meeting point has to be the starting point. So that means whenever Q and R meets, they would be meeting at the starting point. So the time taken by Q and R to meet for the first time or to meet at the starting point would be simply 3600 upon 10 minus 7.5, which will give us 1440 seconds. So that means after every 1440 seconds, Q and R would be meeting and they will be meeting at the starting point. Now, if all these three persons, that is PQR, has to meet, it has to be the starting point. So the time taken by P to complete this track completely or to be at the starting point again would be simply 3600 upon 5. So this would be 720 seconds. So that means P would be at the starting point after every 720 seconds and Q and R would be meeting at the starting point after every 1440 seconds. So the time taken by Q and R and P to meet for the first time or to meet at the starting point would be simply the LCM of 1440 and 720, which would be 1440. So that means after every 1440 seconds, all these three persons, that is P, Q and R, would be meeting and this meeting point would be at the starting point. So the time to meet for the first time and the time to meet for the first time at the starting point would be 1440 seconds. And if they keep running infinitely, the number of points in which they'll be meeting would be only 1 point, and that would be the starting point. Also, the number of meeting points of P and Q or P and R would be more than 1 as they are traveling in the opposite direction. But if all these three persons has to meet, so it has to be only at 1 point, and that would be the starting point. Now, let us consider this question. Two cyclists A and B start cycling simultaneously from the same point on a circular track 1800 meter long in same direction with speeds of 10 meter per second and 15 meter per second respectively. But B reverses his direction every time he completes one round. After how much time will they meet for the first time? Let us consider this as the circular track of 1800 meter length in which A and B are moving in the same direction, that is in the clockwise direction, at a speed of 10 meter per second and 15 meter per second. It has been given that B reverses his direction every time he completes one round. Now here B is traveling with a higher speed than A, so B would be completing the round first as compared to A. So the time taken by B to complete this circular track would be simply 1800 upon 15, which would be 120 seconds. So that means after every 120 seconds, B would be at the starting point and B would be completing one round, post which B will reverse his direction. So that means after one complete round, B would be now traveling in anti-clockwise direction as compared to the clockwise direction previously. Now, after this 120 seconds, A would have covered a distance of 120 times of 10, that is 1200 meters. That means A would be somewhere here after covering a distance of 1200 meters, and at that particular time B would be at the starting point. So now B is here traveling in anti-clockwise direction and A is here traveling in clockwise direction, and the distance between A and B would be 1800 minus 1200, that is 600 meters. And the time taken by A and B to cover this 600 meters would be simply 600 upon 10 plus 15, as A and B would now be traveling opposite to each other. So this time would be simply 600 upon 25, which will give us 24 seconds. So the total time after which they will meet for the first time would be simply 120 seconds plus 24 seconds, which would be 144 seconds. So we can see that in such kind of questions, we cannot use the formulas directly. So that's why knowing the concepts becomes very important, especially in such kind of questions. Also, if you are facing any difficulty to understand these problems, I would request you to go to the previous videos again and then to watch this video to get a better understanding of the problems explained in today's video. So that's it for today's video, which also brings us to the end of time, speed and distance topic, in which we have seen some concepts of time, speed and distance and some word problems based on these concepts. But I would request you to practice more questions because the more you practice, the more you learn. So I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing and keep growing. Thank you.